Hi, my name is Aditya Palaniappan, and today I will be presenting on in-memory databases. So before we can start, we first have to give a rundown of what I'm going to present to you about in today's presentation. So in-memory database is a huge topic, and because of this, I don't think I can be able to cover everything regarding it, but here are the things that I want to focus in today's presentation. So before we can even get through anything about in-memory databases, we first have to talk about what it is. What is the definition of in-memory databases? And so after I talk to you and tell you an in-memory database, the definition of it, and I give you an analogy to help you understand what it is, I'm going to talk about the method in which these databases store data. Then I'll talk about what hybrid databases are and why we need hybrid databases because they're kind of important too. And then after that, I'm going to talk to you about one of the biggest innovations in the in-memory database technology, which is SAP HANA databases. After that, I'll talk to you about the benefits of in-memory databases and some of the disadvantages of in-memory databases. But let's begin with our presentation. The first thing is, what is an in-memory database? And so, as you can see from the definition on the screen, it seems to be a pretty self-explanatory type of definition and term. However, there still might be a couple of terms in this definition that might make it difficult for you to fully understand what it is. So the biggest term that I think people would have trouble with is what is main memory? So main memory is the memory that is directly accessible to the CPU. From this, the CPU can read the instructions stored on there and execute them as required. And as you can see, it's a little different from the disk storage memory. And so as you can kind of see from the graphic below, a disk storage stores all its memory on like a disk drive, and its in-memory kind of has it on the CPU itself. And that's essentially the biggest difference between in-memory databases and disk storage databases. I'll probably tell you a little bit more about disk storage later on in this presentation. But here's another analogy to help you better understand what in-memory databases are. So I like to think of it as like in-memory databases is similar to having a safe in your own house. So instead of having to go to a bank to deposit your valuables, you can kind of just keep them in your safe at your home. And what does this allow you to do? This allows you to be a lot more efficient, and it allows you to be a lot quicker because you don't need to go to the bank now to access your valuables. You don't need to drive there. You don't need to stand in the line. All of this is saved because now you can just access your memory or access your valuables right there in your own house, allowing you to be faster, and it just helps you a lot. And that's kind of how I like to think what in-memory databases are. So now that we know what an in-memory database is, let's talk about how it stores its data. So the first question you might have from the new definition that I have on the screen is, well, what is volatile memory devices? So you already kind of know what main memory database is because I kind of explained to you that on the previous slide, but volatile memory devices is another new term. So what is it? So they are computer memory that requires power to maintain the stored information. So what does this mean? This means that the memory is going to be there when the power is on, but then when the power is turned off or reset, then you lose the memory. And while this may seem a little counterintuitive, why would you want to lose the power? Or why do you want to lose the memory when the power is turned off? And so we kind of have a way to rate databases, and it's through a system called ACID. And so we want databases to have atomicity, consistency, isolation, and durability. And so from this, as you can kind of assume, we might not have the greatest amount of durability with in-memory databases because, well, it's not durable. You lose the memory the moment the power turns off. So that's one of the biggest problems with in-memory databases. And so how do they solve this problem? Because this is a pretty major issue. It's kind of useless if we don't resolve this issue. So how do in-memory databases solve this issue? And for future reference, I'm going to now abbreviate whenever I have to say in-memory databases. I'm just going to abbreviate it to IMDb. So how do IMDb solve this issue? And it is through some of these following mechanisms: transaction logging, non-volatile DIMM, non-volatile RAM, high availability implementations that rely on database replication, and some other mechanisms that I'm not going to go through because, well, there's just so many things involved with IMDBs that there's other things that I need to talk about. So, hybrids. Why do we need hybrids? What's the necessity of hybrids, and how are they useful? So, as you can imagine, there's a lot of advantages to using IMDBs, and because of this, you might wonder, well, why do we need hybrids? Because, well, IMDBs just seem so useful. And the truth of the matter is, they are so useful. There's so many advantages with using IMDBs. However, unfortunately, it's a pretty expensive method of storing data. So a lot of companies always just want to save money, right? And they don't want to use the most expensive tool out there, and they want to try using other cost-effective methods. So, well, that's where hybrids come in. So hybrids is when you use both IMDBs and disk storage methods to save your data. So what type of memory are you going to save in memory, and what type of data are you going to save on your disk? And this kind of and so this is really dependent on, well, what is the most frequently accessed data. And so you want to keep the most frequently accessed data in memory and then all the other data on a disk. And because you have your frequently accessed data in memory, you can still access that with really great speeds, and you can so that saves you a lot of time, and it's still really efficient. And then the other data that you might not use as much, well, that's going to be stored on a disk. And so this allows there to be a great flexibility. And so what does this flexibility allow? This flexibility allows there to be a balance between performance, cost, persistence, and form factor. And so because of this, hybrids are really how most computers are set up. And, well, it just allows there to be, there's just so many advantages of hybrids that, well, maybe IMDBs don't really have just because IMDBs are so expensive. So now that you know the definition of IMDBs, now that you know how it kind of stores data, now that you know what hybrids are, I want to talk to you about the next biggest thing in IMDBs. And this is one of the biggest innovations in like IMDB technology, and that is SAP HANA. So SAP HANA is a database server that stores and retrieves data as requested. And while it does this, it also simultaneously performs advanced analytics and includes ETL capabilities as well as an application server. SAP HANA is a type. So, what type of database is SAP HANA? Well, SAP HANA is a type of column-oriented in-memory database. Well, what does that mean? It means that HANA stores all data for a single column in the same location rather than storing that data in a single row. Well, what does that really achieve? What does that allow? Well, this allows for performance improvements for OLAP queries on large data sets and allows for greater vertical compression of similar types of data in a single column. And so what does this allow? This allows HANA to support huge volumes such as a petabyte of data in memory, and while doing this, it is still able to return query results in under a second. This unparalleled speed and efficiency is what makes SAP HANA to be one of the biggest innovations in memory databases in recent years. And so because of this, SAP HANA is huge. It can store so much data, it can retrieve your data so quickly, and because of this, it just allows there to be great efficiency, great speed, and this is just very useful, and there's so many advantages in using SAP HANA. So, now that I've talked to you about a lot of topics in IMDBs, let's talk about the advantages of using IMDBs. And hopefully I've hammered through some of the advantages in this presentation, because there's just one huge advantage to using IMDBs, and that's speed, efficiency, and performance. They're all just basically the same thing. Just you have unparalleled speed, you have unparalleled efficiency, and unparalleled performance. As I've already explained with SAP HANA, you can store up to a petabyte of data in memory, and while doing this, it's still able to return query results in under a second. This is crazy fast, this is crazy efficient, and because of this, IMDBs are just so advantageous. and it's just amazing. It really changed how we use computers and how we use